Sorry, I'm late. 4 minutes. Ay, ay, ay. Your cyber doctor is always late. What the hell? What the hell? Alright, I'm gonna close my shirt a little bit. A little bit. Just a little bit. How is everyone? There's probably no one. No one's here watching at this time. I think. But if you're here, say shirt. Yeah. Good folks. Today we're learning about LLMs, the deep core of them, like how they work. How they work. In terms of like vector and stuff like this. I mean, vector, I get it, because it's a large language model. It makes sense that there's vectors, right? That transformers move pieces. But there's some saucy things here going on that we don't necessarily understand. And we must understand them. Otherwise, our lives will end. All of them. I'm just kidding, yeah. Just kidding. But it'd be nice to know. It'd be nice to know in order to hack it better. Excuse me. It's not even sneezing season. I don't know what's going on. We should only sneeze during sneezing season. There's like a season where it's acceptable. No, but it's strange that I'm sneezing right now. It's not a typical time. Oh, I think it might be playing on my AirPods. Full volume though. It's playing at the TV level. Spatial sound. No, just play the regular. Is it blasting your ears? Yeah, yes, completely blasting your ears. It's completely blasting your ears. Okay. Alright, door's closed, so that's good. Partner's not gonna want to come out and murder me. Anyway, folks, we're here. We're here, and we're gonna learn a little bit about some of that sweet LLM security. Alright, so what are we going here? Let's just check out if this works. It doesn't work. God damn it! I don't know why it doesn't work. But we're live. I swear we're live. Alright, anyway. Let's talk about, we wanted to learn, okay. I don't want, well, let's go on ChatGPT. We haven't been on ChatGPT in a long time. Let's go into ChatGPT and ask, okay, how are LLMs working? I want to look into the deepest level of how LLMs work, like vectors, bits, etc. What should I look into? What topics should I look into? Vamos. Before AI, understand how computers think. A number, bytes versus bits, hexadecimals, integer representation, floating point, memory, RAM, CPU cache, GPU memory, matrix storage. Yeah, we kind of understand that, but not really. Floating point, not really at all. Shall we? The language of AI. What should we focus on, folks? There's vectors, magnitude, direction, dot point, cosine similarity. Higher dimension is tensors. Eigenvalues. Oh, I've heard this before. Definitely heard this before. Similar value decomposition, SVD. Sounds like a drug, SVD a bit. You should come out comfortable with statements like embedding 768 numbers, weight matrix this much, output vector length. Probability. I think we know about most of this. Softmax, you'll understand why model output cat is equal to dog is equal to that, instead of just cat. Level 3, calculus. So folks, if you're here joining just now, and you're wondering what the heck is going on, and you want to feel like being aggressive, it's completely normal. Completely normal behavior. No need to see a therapist. We want to understand LLMs all the way down. It gives us it gave us a full thing to go into. Like a different level kind of thing. And I'm pretty down to go into that. We could start with level 0. Level 4, neural networks. Learn the basic building blocks. Topics, perceptions, weights, biases, activation functions, ReLU, GeLU, sigmoid. I think it's the shape of a... Oh, there's not the thing in back. Sorry folks, I did leg day like 2 days ago. And you know how that second day is. It's the worst. It's the worst. But hey, leg day is fun. I kind of like leg day. So there's a bunch of things, loss functions you'll understand. Input, linear activation, linear layer output. Level 5 embeddings. Cat, and then this. Now this we do not understand. This is where the language becomes math. Words become vectors. Example, cat becomes this. And 768 numbers. Important ideas, embedding space, semantic similarity, cosine similarity, and nearest neighbor. Level 6, tokenization. Oh my god. So that's level 7, because there's a level 0. LLMs don't read words, they read tokens, learned by pair encoding. Sentence piece, word piece, UTF-8, vocabulary, special tokens. Unbelievable. Wow. Transformers. This is the heart of model LLMs. Learn attention, self-retention, self-attention, query, key, value. This is what we wanted to look at initially. Key and value. Attention scores, skill dot production attention, multi-head, attention, residual connection, layer normalization, feed-forward layers. Positional encoding. This is where most of the magic happens. Training. Topics, dataset creation, pre-training, tokens, epoch, batch size, optimizer, atom, learning rate, grading, clipping, loss, checkpoint, fine-tuning, gratitude. Hey, gratitude. I'm doing good. Doing good. I woke up very rested today. And you, gratitude, how are you today? Inference. Oh my god, there's so many levels. Inference, how ChatGPT actually generate text. KVKH, sampling, temperature, top K, top P, beam search, logits, streaming generation. We know about streaming, but probably not that kind of streaming. Top 10, level 10, model internals. This gives the current research. Mechanistic interpretability, circuits, neuron features. My god. Hardware, tensor cores, information theory. This is what we were told to study on Monday. Doing great, thank you. Nice. What's the plan for today? Today I felt like we could go into a bit more of the learning the LLMs, like deeper core, how they work. Like I'm not sure if you were there on Monday. I don't think you were. Gratitude 2020. We had a large debate about this idea, information theory. And so we're going to spend a bit of time today to learn on how how large language models work and computers in general in order to be able to hack them better. This is the idea was today. Hey, what's poppin' today? Rouse AK. Hey, good to see you. Dancing dinosaurs. Nice. Doing good. Doing good. What's popping? We going over what the different levels of AI. Let's say we want to get better at LLM hacking, as you know. And so one thing that I've been wondering is how LLMs work, tokenizations, things that they do, embeddings. And Claude came out with 15 levels. 15 levels to look into. Holy moly. Holy moly. Starting with like computers. Starting with literally computers. Linear algebra. Folks, if there's one thing that I did that I think was a mistake, well, I don't know if it was a mistake. A misunderstanding I had initially is how much computing is about math. Like, if you really want to get down to it, if you really want to understand how things work, you have to be good at math. You have to understand some pretty core. Because all it is binaries. I mean, all computers are is binaries, kind of on steroids. Just like the core idea is simple, but what you do out of it is very different. Cyberpunk Reno sending us some binary. All right, we have to decrypt that. Computing is forcing rocks to do math. Forcing rocks. Rocks in the computer. What is it? What rocks are there in a computer? You're gonna need to decrypt that for safety. Alright, it's coming from Cyberpunk Reno, so it's pretty trustworthy. Hey XR, if it came from Rabbit Paperclip, I'd be a bit more suspicious. No offense to any Rabbit Paperclip that may exist on this chat. Cyberchef. Le Cyberchef. Decode this. From binary. Hello, Doc. The AI hacking, it sounds like this. It goes like this. 1010110. Nice. Oh wait. It's funny how this takes this much space. Like just this takes this much space. Hello, Doc. That's crazy. That's a really good platform, eh? What they made on the you can't see on Cyberchef. The AI hacking, it sounds like this. How do you do the question mark? Question mark is a full byte. Nice. Thank you for that enigma, Cyberpunk Reno. Computing is forcing rocks to do the math. It cut off because it reached a character limit. Oh man. Okay. So there was probably something at the end. Silicon is one rock, copper is a metal that comes from a rock, gold, etc., etc. Yeah. True. I actually didn't. It's all rocks. Everything is rock. I mean, I don't know if you know this song from Moby. It says, "We are all made of stars." It's a pretty sick saying, and it's true. We are made of stars. Like computers are made of rock in the same way. Moby is the goat. I like it. I like Run On. I haven't listened to this one. Run On from Moby. I used to listen to Moby quite a lot. Run On. I don't know who wrote what Run On is. I used to listen quite a lot to this album that he made called Innocent. It's quite nice. Computers are just rocks that carve with arcane symbols and change with electricity and force to think. Yeah, true, huh? Poor rocks. I like Run On. Actually mind-blowing. Are you talking about the music here, Run On? It's insane how we forced rock into slavery, into computing things for us. When you think about it, it's exactly what we did. Slavery. Oh yeah, you want to take a break? Well, no, you're in a data center. You work all the time. Until you die. Poor rocks. No, the computers. Yeah. Computers are really mind-blowing. I agree. Well, let's look into them. I've no binary numbers. Let's start here. Binary numbers, bytes versus bytes. Kind of get it, no? But I think I do, but I'm not sure. Hexadecimals. What do you want to look at, folks? Do you want to start here at level 0, or do you want to start at level like 4? Neural networks. Tokenization maybe as well. Which one makes your heart beat? Which one makes your blood flow? Transformers, that could be quite nice. Self-attention, attention scores. Training. Not sure what ePush means. Pre-training, dataset creation, learning rate, greeting, clipping, loss, checkpoint. First memory were copper wires woven into magnetic donuts by 1 inch slats, if I'm describing that correctly. God damn, that sounds pretty damn primitive. Today we've optimized our rocks. A bit more than back then. Level 9 inference. How ChatGPT actually generates text. Context window, KVKH, sampling, temperature, top K. I have to sneeze. Model internals. This gets current. All right, let's go at the beginning. Okay, let's go at the beginning. CPU cache, because I have no idea how a computer is made. I'm gonna take my notebook. I think it's a great time to take out my notebook. Let's go for it. Do we take notes here, or what do we do? Wikipedia core rope memory. Ooh, I'm down for that. Soviet RAM. Core rope memory. Let's hope that we won't have the white screen of Wikipedia. We won't. Wonderful. Let me go get my notebook. I want to take notes on this. Can't find it. 1 second. Found it. It was in a different pocket than usual. So Ross is convinced that computers are actually magic. Yeah, I agree. Like even electricity. Like why does this need charging? Isn't it just a trick to get me to upload my data to the NSA? Like what the fuck is electricity? What is this right here? My lamp that I'm using, right? You don't see it, but why does my lamp have a battery? Like why doesn't it just work by itself? Like in what world does this make sense that I need to like shove it into a wall and then it charges and then I pay at the end of the month the magicness of it all? Like you have to pay your magician. When you think about it, when you pay your electricity bill, you pay for all the magic that you use that month. I agree, we must have to I'm convinced computers are actual magic. Yeah, same. Agree, and one must have the correct techno mojo to make them work properly. Well, we could go down a rabbit hole, but I like to think everything on Earth has a purpose, a pulse, life in a sense at least, for example. I used to think that was bullshit, Ross AK. But I think over the years, as I became older and wiser, I agree more and more with you. AC versus DC and the amperage versus wattage versus voltage. Alternative current and discontinuous current? And the amperage versus wattage versus voltage. You have a coax cable, which is copper with dielectric coating and aluminum shielding. This is used for cable signals. Plug it in and bam, you can connect to the internet. Direct current. Connected to the, yeah, it's crazy. Dude, it's crazy. And just like that, you guys are watching me on the internet, a person that's probably an ocean away. Maybe I don't even exist. You guys don't know. You don't have proof that I exist. I don't have proof that you exist either. I have even less proof than you guys that you exist. Wow, what if you all had been LLMs this whole time? What if I've been a deepfake this whole time? That'd be cray cray. Cray cray. My latest notes were about the CISSP, folks. Certification I'm doing on the side. Radio waves are just alternative electronic currents. Hey, you exist to feed my parasocial socialization. Yeah, same. Same cyberpunk Reno. Alright, gotta ban that person. Ban. Oh, banned. Cyberpunk Reno, thank you very much. 10 seconds ago. Hwaja! Cyberpunk Reno is a ninja. Alright, Rouse AK. Yeah, same, huh? Hey, you exist to feed my parasocial socialization, lol. Same. Same to you. Rouse AK, now let's say one day you can't connect to the internet. I run check and I find the cable isn't good. Let's say it's never been touched. It just sat in a clean environment, but test shows the cable isn't good. I replace it, bam. You can reconnect to the internet. It's crazy. It's crazy, I agree. What exactly is the reason the cable, in all senses, is a good cable, just stops carrying signal at all? Yeah, I agree, yeah. Like, I was asking, you know, for the CISSP, I need to understand a bit about networking. And networking is my weakness. And connected to what you're saying, like, cables are not good. Why do some packets get lost? You know, packets of data. Packets is layer 3? Yeah, packets is level 3 of the OSI model. And they get lost all the time. Packets get lost all the time. But so yeah, packets get lost all the time. So yeah, why does this happen? Why aren't things like not perfect? And this is what you say, Ruff's AK. Like, why aren't things perfect? Like, why isn't this cable like working perfectly? Just stops getting signal at all. It's like, it's things that don't make sense. It has to do with ingress mainly. Merber. Man, Ruff's AK, you should just come to Barcelona and do the CISSP for me. Signal declaration is a signal to become signal degradation, as in the signal becomes too weak to reach the destination in the proper data. Interesting, I like it. It has to do with ingress mainly. Ingress is when you upload something, no? Or you get something. Ingress. World War III. Oh, did you ever play this? That was a thing in like 2012. Ingress define means the act of entering, the right to enter, or a place of entry. Is it user end? Is it plant end? That's the question. I'd probably fail it. No, ingress is a form of inference. Oh, man. That ingress AR is a prototype for Pokemon Go, lol. Yeah, I agree. Did you folks play Pokemon Go? Look up ingress on Cokes. is the unwanted entry of external radio frequencies. Interference into a cable system commonly caused by loose connectors, damaged shielding, or poor quality spillers. Part 2, chasing ingress. On TikTok. Holy moly. Four-way splitter. Holy shit. We could go so far into what we're doing. Cable testing, troubleshooting. God damn. People's setups. Is that an office or just a home? Are people just doing this at their home? Looks pretty ugly, huh? But hey. Look up Ingress on Cokes. I play Ingress on in high school, lol. Oh wow. We have NNT teams. That NNT was Pokemon Go, no? They have to track Ingress over entire zip codes. Damn. I have to fix people's setups every day, lol. Cause Rouse, you work as oh right, you work as support, no? IT support. Oh right, you install internet at people's houses, if I remember correctly. Rouse, no? Let's track the code. We're like a cable tech plus. Let's track the cable management. Lol. Actually, let's not have cable spaghetti. Cause I do a lot more too, lol. Damn, man, that's pretty tough. It's a lot of things. All right, core rope memory. Let's look at that. Core rope memory is a form of read-only memory. ROM for computers. It was used in the UNIVAC 1, Universal Automatic Computer, and the UNIVAC 2, developed by the Eckert Mauchly Computer Corporation. In the 1950s, it was a popular technology for program and data storage. In that era, it was later used in the 1960s by early NASA Mars space probes, and then the Apollo Guidance Computer, AGC, which was built by Raytheon. My god, such a boring looking business. Look at that image. Just look at it. Would you like to work there? I mean, I don't know. Maybe it's not that bad. Maybe you get paid okay. But that building's pretty dead looking. MIT, man, MIT was so instrumental in computers. It's a private research university in Cambridge, Massachusetts. The university has played a significant role in the development of areas such as technology and science. Yeah, honestly, MIT is like the bomb when it comes to this place, to science. And look up a photo of it. Looks like a Soviet RAM. Soviet RAM. Is that what you mean? Is that what it is? Ah, this is what you were talking about. Copper cables inside of rings like this. Soviet era core memory. Holy moly. This is what it was. There's no way. How does this still work? Playing with Soviet era ferrite core memory planes. 10,000 likes. It's a lot. It's a lot of views. Still works. Wow. Holy shit. There's so much to learn about. Core memory rope. Isn't that psycho? It is completely psycho. Still works. Is that memory? It says 1024 bits. We hook up two Soviet era ferrite core memory planes obtained on eBay, and they still work. In fucking sane. Insane. I quit Android. There's so many good videos that look interesting. I quit Android, and she put a freaking Android on there. If I have a business alone for 6 days. All right. Cool. It's fucking psycho. I agree. That's psycho. Absolutely. All right, folks. So for those of you joining and thinking like, what the heck is he doing? Looking at Soviet equipment. So folks, I asked not Claude but ChatGPT on this one. We decided to change today. We wanted to work how LLMs work at a core, and what topics should we look into. And I wanted to look at level 0, how computers represent information. And we got down to the really bottom of computing. And I have a notebook here and a pen. And I would like to talk about these different things that ChatGPT is talking about. So yeah, this is going to enable us to hack better, because we're going to be able to understand computers and LLMs better. And we're going to be able to hack obviously better. Obviously. Bits versus bytes. I'm actually interested in binary numbers is just ones and zeros, no? Okay, teach us level 0. Isn't that the same thing? Bytes versus bits, it's different. No, it's clearly different. Electricity, the real foundation. Oh my god. Just how we talked about it. Electricity is the real foundation. At the lowest level, a computer isn't thinking. It's controlling billions of tiny electronic switches called transistors. Billions. A transistor has 2 useful states. Off or on. Okay, let's write this down. And I'll show you my notes afterwards using the webcam. Okay, so let's write computers. I really don't like this pen. Do I have a better one? And one thing I did, folks, I lived in the US for 6 years. And during that time, when I was a kid, we used to... So let me tell you about myself and my theory about pens. This one's great, but it doesn't work. Ah, it's back. Fuck. I'm such an ass. I grew up in I grew up in France. And I lived in the US for some years as well, for 6 years, which is why I don't speak with a very strong French accent like I could right here. And when I was in France, we were obliged to take some really nice pens. We had to take the ones that are old school with not a ball, but like one where you had to have ink inside. You had to have ink inside and you had to write like properly. And you have to do things right. And then afterwards, it kind of got like, okay, you can start writing with regular pens now because you know how to write with the fancier pens. And when we got to the US, it used to be the shit where like no one was giving a damn about what they were writing with. You could write with a pen, you could write with a pencil, you could write with whatever you wanted. Like it didn't really matter as long as you wrote and it was kind of understandable. In France, if you wrote poorly, you would get smashed. And I got smashed a lot. As you'll see, my handwriting is not great. So, yeah, in France, we used to pay a lot of attention to our pens. But in the US, it was just really like, fuck it, write with something. Whatever you want. All right. So, folks, we're looking at the deep ends of a computer so we can learn how to hack it better. So, transistor has 2 useful states. A computer controls billions of tiny electronic shiz which can go on and off, which go on and off. All right, they go into between on and off. Damn. Think of it like switching a light. The computers use voltage. 0 volt approximately means off, and it means 0. But if there's a little bit of electricity, but there's a little bit of electricity, it goes 1. 3.3 volts or 5 volts, depending on hardware. Oh, well, interesting. Then it's on. Notice something is important. The computer doesn't know what 1 means. It knows electricity exists or electricity doesn't exist. Damn. Cyberpunk Reno says, hey, my handwriting is a combination of what and the hell with a dash of is this? I'm curious to see. You folks will see my handwriting here. It actually fits the Cyber Doctor personality quite well. On and off. The computer doesn't know what 1 means, and it knows electricity exists or electricity doesn't exist. Bit is a small piece of information. Bit is equal to binary digit. Okay. Bit is equal to 1 or 0. Okay. A single bit can answer a yes or no question. Bit is equal to 1 or 0. That's it. I mean, I don't see what else to take more on. Door open, closed, rain, yes or no. More bits is equal to more information. In 2 bits, you get twice the amount of information. You get 4 possibilities. Write nose, go back a week later. What did I write? Typical, huh? Same though, for real. That's the point of going back. You can maybe read your notes again. But I don't know what kind of crazy person does this. Notes are all about writing and never reading again. I have some pretty nice notes in there. Maybe I should spend some more time learning about them. There's some really good stuff about life and stuff like this in here, huh? I had, for instance, in June, I made a mid-year resolution. I have a lot of things about insurance as well, about cyber insurance. These are some good stuff, huh? These are some really good stuff. And I have things about finding sunglasses, for instance, as well. Because I was looking for sunglasses. Kuberos. Authentication mechanisms. Damn. Some good stuff. I should read over that again. Performance review. Anyway. I can write fast or I can write legible, but I can't do both, Lolia. Classic. Classic, classic. How many possibilities? 4. Okay. So we have 8 possibilities. When we have 3 letters, we have 8 possibilities. Okay. Pattern 1 bit is equal to 2 values. 2 bits, 4, 16. Wow. It really starts increasing at 8 bits. 32, 64, 128, 256. Yep, makes sense. 16 bits, we have this many values, and 32 bits is equal to 4 million values. So what does it mean when a computer is on 64 bits? Does that make sense to you folks? N bits, N possibilities. What does it mean when a Windows computer is on 64 bits? Excellent question. It's actually one of the most misunderstood concepts in computing. When someone says my Windows is 64-bit, they're really talking about the CPU architecture, and more specifically, the size of the value processor it is designed to handle most efficiently. Imagine the CPU is a worker. The CPU constantly moves data around. Suppose the worker has a basket. A 32-bit CPU. This basket can carry 32 bits at once. a CPU will carry twice as many. Okay, so far, pretty good, right? This doesn't mean everything runs exactly twice as fast, but it means that the CPU is built to naturally process larger values and addresses. This doesn't mean everything runs exactly twice as fast, but it means the CPU is built to manually process larger values and addresses. Okay, so 64 bits is simply a binary number that is up to 64 digit long. For instance, this 64-bit number would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is probably exactly 64 bits long. That's a 64 digit. That's 67 binary digits. Why is that important? Because the CPU uses those bits for many things. It can create numbers. It's over 18 quintillion. That's a lot. Folks, we're really learning the deep ends of the computing. Memory, so CPU 64. So when we say Microsoft 64, (64-bit) means that the what is it called? The CPU? Yep. CPU features FEATURES. The CPU features 64 bits. So it means that there's 64 connectors on the CPU, no? Okay, now I kind of understand why there's 64 of it. I think it's easier if it's a multiple of 2. Because then you can process bits, like a whole number of bits. Because if it's 65, it starts to become really annoying, you know? It's like, bro, we're left with an extra connector, but we don't know how to use it. Because it's not a multiple of 2. It would kind of suck, no? To have more than that. Memory addresses, the biggest reason. Imagine RAM as a giant hotel. Every room has an address. Room 0, room 1, room 2, up to room 1 million. That's a pretty big hotel. I'm not sure where you'd need 1 million rooms, but anyway, the CPU must specifically address whenever it wants to read or write data. If an address is 32 bits, then the number of possible addresses is 2 to the power 32, which is 4.3 million. No, billion. If each address refers to 1 byte, 4 billion bytes is approximately 4 gigabytes. 4 billion bytes is approximately 4 gigabytes. That's why old 32-bit Windows systems could use only about 4 gigabytes of RAM. This is why old 32-bit Windows systems could only use about 4 gigabytes of RAM. What does that mean? Hold on a second. So the CPU and RAM are proportional? The fuck? So CPU and RAM are proportional? I'm not sure what I mean by that. I'm not even sure my question makes sense. Not exactly. They're related, but they're not proportional. CPU is the chef and RAM is the kitchen counter. Okay. Storage SSD is the pantry or the massive fridge. The chef CPU does the work, but the router RAM, but the counter RAM is where the ingredients are laid out while cooking. What the CPU does. The CPU performs operations like 5 plus 7 is equal to 12. Multiplying these two matrices. It is constantly reading from RAM. what RAM does. RAM simply holds the data that the CPU is currently using. For example, if you're editing a document, load Microsoft Word, RAM, CPU execute instructions. Okay, CPU doesn't permanently store the program. It repeatedly fetches instructions and data from RAM. Where does the 64-bit come from? A 64-bit CPU can use 64-bit memory addresses. Think of it, RAM is a street full of houses. Each house has an address. The CPU needs to say, go to address this much and give me the data. If the address is only 32-bit long, there are only about 4 billion. Does that make sense, folks? Four gigabytes, okay. So how much memory could a 64-bit CPU have? Put that into perspective and say why. How much memory do the largest computers have today? So 32 bits, that kind of makes sense, no? What I'm saying here is that the number of the CPU can only address a certain number of places in the CPU. That's why it can only work with 4.3 gigabytes of RAM. Makes a lot of sense, no? Old Microsoft 32 bits could only leverage 4.3 G. Oh man, my pen. GB of data because it's all the addresses it could reach. Nice. All right, so this is one of these questions where number becomes almost unbelievable. Theoretical limit of a 62-bit CPU is 2 to the power of 64, which is 1, 2, 3, 4, 5. That's hundreds of thousands. That's millions. That's billions. So basically, it's millions of billions. That's a lot. 18,000 terabytes. That's a lot. So the theoretical space is about 16 exabytes. An exabyte is enormous. Gaming PC will have about 32 to 64 gigabyte RAM. Wait, hold on. A modern smartphone? We're talking about storage here. We're not talking about RAM. A modern smartphone. I thought AI just completely hallucinated here. Yeah, gaming PC will have 32 to 64 gigabyte RAM. Damn, I wish I had that. High-end workstation will have this. Hey, thank you very much. Followers goal 290. Who followed us? Oh, too bad I didn't hear. Let's go see. Overall chill, we have Grow Mint. No, thank you very much. Yay, thank you, Ross, for celebrating. Awesome. 290 followers. That's really cool. Thank you very much for following Gromit. And Ivan Loliver. Thank you very much, Ivan. I didn't notice. My sound is not high enough, I think. I need to decrease that music volume so I can hear you, the notifications better. But now I need to adjust it in Twitch. Thank you very much for the follow, guys. I appreciate it.
Ivan Loliver, thank you very much. Nice, increasing the music a bit. And Grominto as well. Gromitinho. Nice, thank you guys for the follow. Appreciate it. So folks, if you're just joining us, we are taking notes right now on how computers work. We are hacker specialists and we're specifically in AI hacking. And sometimes it feels like we're stuck a bit by our understanding of computing. And so we're going back to the lower ends of how computing works. And we're putting things into perspective. And we're realizing that just basic rocks, things that we consider rocks, like silicone and different minerals that are make up computers, are extremely impressive. And we've gone a long way in terms of computing. So what we learned so far is that a computer controls billions of tiny electronic switches, which go on and off, like light switches. So that's really cool. When we talk about Microsoft 64, it means that the CPU features 64 connectors that can go on and off. And this, as ChatGPT calculate for us, this is 2 to the power of 64, which is 18 million billions possibilities. So really a lot of possibilities. So yeah, a lot of possibilities. So when we used to say 32-bit models from Windows, they used to have this limitation where they could only use 4 gigabytes of RAM. And now that we switched to a 64-bit, we're clearly not having the same problem because numbers like this are exponential. Well, you're learning. Oh, thank you very much, Ivan. Loliver. I like your name. And you like what I said? Awesome. Well, thank you very much for following. So yeah, it's all about bits. So yeah, we don't have the same problem anymore. This is why I think we've already asked this question on stream, where we said 64 bits. 64 bits is it's not going to change anytime soon. 128-bit CPUs aren't coming because I think this is for that reason. We still have so much more to explore in this territory of 64 bits. Maybe let's ask, what would it bring? Oh, thank you very much. Ross AK offers 1 subscription to Ivan. Well, that's really sweet of you, Ross AK. Damn. Cyberdoc is a G. Oh man, you're so kind, Ross. Thank you very much. You really gifted a lot of subs and stuff. Yay, Ivan with the little star next to it, subscriber. Congratulations, Ivan. And thank you, Ross, for gifting the sub. That's really cool of you. And Ross is a great supporter. And Ross is the only proud owner of a Cyber Doctor merch. Won honestly through a contest 77 streams ago. God damn, it's been no, it's for day 150, so it was 27 streams ago. Yay, thank you for sharing the Discord XR. Appreciate that. All right. So, would there be let's ask first if they exist. Are there 128-bit CPUs? Are there 128-bit CPUs? Do you think there would be an advantage to having more? Whoa, shit. What the fuck happened? Store persistent storage, I'm okay. To having, do you think it would be an advantage to having such CPUs in current day? This is a fantastic question because it gets to the heart of computing architecture. Oh man, don't you love it when ChatGPT kisses your butt and tells you how fantastic your question is? The short answer is no, there are no mainstream 128-bit general purpose CPUs, and for today's computers, they would be almost no benefit. Let's see why. What does the 64-bit actually improve? Two main improvements over 32 bits, larger integers and larger memory addresses. The second one is by far the more important. Larger memory addresses. So this was the RAM issue we ran into before. 8 bits per byte. Did I get the two confused, Rouse AK? I might have said bytes instead of bits, or the other way around. 128 bits would give us, instead of being able to do this, 2 to the power of 64, we have 2 to the power of 28. How big is that? 64-bit is absolutely massive. And 2 to the power of 28 is large. It looks like telephone numbers when we'll be all over space. That's approximately 340 undecillion bytes. It's so large that common storage units, kilobytes, megabytes, terabytes, petabytes, exabytes, terabytes, yettabytes, make it intuitive. Barely make it intuitive. All right, no need to put into perspective. We know how big it is. Alright, so why stop at 64-bit? Because engineering is all about trade-off. If every pointer becomes a 120-bit instead of 64-bit, instead of 8 bytes, it becomes 16 bytes. Every pointer doubles in size. That means that programs use more RAM, CPU caches hold fewer pointers, memory bandwidth is wasted, many resource structures become larger. You'd make almost every program slower while solving a problem nobody currently has. That's pretty accurate. Solving a problem nobody currently has. Here's the funny part. Most 64-bit CPUs don't even use all 64 address bits. For example, a modern desktop CPU might only use around 48 bits for virtual addresses, around 42 bits for physical addresses. Why? Ooh, what is the difference between virtual and physical address? Now let's just finish here the point. Because 2 out of power 52 means 4 petabytes of directly accessible physical memory is already far beyond what today's systems can install. The remaining address bits are reserved for future expansion. Okay, so it's kind of like use what you can at the moment. But CPUs do use 128 bits operators. Modern CPUs often have registers that are 128 bits and even more. Okay, these do not make a CPU a 260-bit CPU. Instead, they let the CPU process many smaller values in parallel. For example, instead of adding one 32-bit number, it can add 8 32-bit numbers simultaneously. Yay, thank you very much, Omar, for following. Omar252, hello. Welcome. Hi, Ro. Hey. What's the difference between physical and virtual address? That's a good question, no? Excellent, this is where computer architecture is getting really exciting. Interesting, excuse me. Once you understand virtual memory, you'll understand why modern operating systems are so powerful. Let's start with a world without virtual memory. Okay, so physical address. Imagine your RAM is a street of houses, from 0 to a large number, with a lot of nines. Each address corresponds to 1 byte. Byte, not bit. As correctly pointed out by Ross AK, it means that we have 8 bytes. Bytes. Man, they should have called them different. Like burgers and fries or something. We wouldn't mess it up that much. Each address corresponds to 1 byte. A physical address is the actual location on the RAM chips, not chimps. Jeez. If the CPU asks for address 5000, it literally goes to byte number 5000 in the RAM. Simple. Okay. So physical address is the actual location in the RAM chip. Ah. So physical address is the actual location. Damn. Damn. All right. All right, let's see it. So physical address is equal to the physical number of bits. Physical position on a RAM / CPU and everything. So it literally goes to the byte number 5000 in the RAM. Simple. The problem, suppose you run two programs. Program A needs memory 0 to 1000. Program B also needs 0 to 1000. They can't both occupy the same physical RAM. Someone has to manage this. Instead of letting programs use real RAM addresses, the operating system lies to them. Every program believes its own memory starting at address 0. So program A says 0, 0, 0, 1, 2, 3. Program B also sees 0, 1, 2, 3. But the operating system secretly maps them to different places. Okay, so virtual address is a little bit more difficult. Virtual address is an allocated spot SPOT in the RAM CPU for a certain gram. Programs need to start at 0, therefore the, what is it called? The OS creates many starting bytes for these programs. That's really cool, no? For example, program A sees 0, 1, 2, 3. Okay, program C sees the same thing, but the operating system secretly maps them to different places. I wonder what they would think if they, if they knew the programs that they were being lied to by the operating system. How pissed off do you think they would get? I mean, if I'm told I'm at address 0 and I'm actually at address 1 million, I'd get pretty pissed, no? I think it's only natural to get pissed when you're being manipulated into thinking you're the most important because you get to start at 0, and it's not true. It's like as if I said it's like if you said it's like if you're starting to date a lady or a guy, and they say, oh yeah, you're the most important one, and then you realize you're actually the millionth most important one. Like, you get pretty pissed, right? I mean, I know I would get pissed. So I think programs are actually a little upset if they would know that they're actually not on RAM 0. So yeah, just a quick thought. Program A, virtual address 0, physical address 2 million. Okay. Both program thinks they're writing to address 0. They're actually writing completely different RAM locations. That's okay. Try being PID1. What is PID1? Try being PID1. What is... Ooh, Purpose Drifter is here. Is it PID1? It has to happen. It has to happen because everything is sandbox. So unless you're at address 0, programs with array all 0, base must be different addresses space because everything cannot exist in the same space. Yeah, I agree. But, you know, if I were one of these programs, I'd be pretty pissed off. Great question. PID1 is the most important concept in operating systems, especially Linux. It also connects nicely to what we just learned about processes and virtual memory. What is PID? Every program on Linux is called a process. Ooh. We kind of knew about that, no? We've been working on Linux quite a lot. The operating system gives every process a unique number called process ID. Example. Process ID 1 is init. Process ID 245 is SSHD. Imagine being PID1 for it's for init or systemd. Why is PID1 special? When Linux boots, the kernel is the first thing that starts. The kernel then launches the very first user space process. This process always gets PIDs equal to 1. This process becomes the parent of almost every other process in the system. Well, this is what you mean, Cyberpunk Reno. Being PID1, it gives you a lot of power, right? But as a wise person once said, with great power comes great responsibility. All right, so you're basically the daddy, the mommy and the daddy. If you're PID1, you create everything else. You're like Jesus or God created everything on earth. Think of that as the root of a family tree. Kernel PID1 starts different thing and then starts different thing. Why does PID1 exist? Someone has to start system services, monitor them, restart them if they crash. Shut them down cleanly. PID1 is responsible for all that. And who backs up PID1 in case of PID1 fails? And also said absolute power corrupts absolutely. Ring 0. So ring 0 fixes PID1 if PID1 fails. Python my program. Now imagine Python crashes. What happens to my program? It still exists. It has no parent anymore. Oh man, that sounds like the person that said, with great power comes great responsibility. Isn't this Batman who said this? With great power comes great responsibility. How bad is it without light? Kind of bad, no? Kind of bad. We'll keep the light on. This process is called reparenting. The kernel will make place when its new parent. Ah, okay. Wow. PID1 adopts orphan process, so they're still managed. Wow, damn. PID1 really is the goat of computing. What does Docker talk about? What does Docker talk about PI1? This is where many developers first encounter the term. Inside a Docker container, there is usually one main process. For example, Docker file cmd python app.py. Inside the container, you have PID1 and python app.py. Notice something. Python is now PID1. As Spider-Man? Wait, no. Whoa, Purpose Drifter is spilling his wisdom. Ring 0, this is where the kernel resides. Dwight Eisenhower, US President. Oh, you're talking about Docker Kubernetes. Spider-Man's uncle. I'm not very familiar with that. I think it's Batman, no? That says this. With great power comes great responsibility. With great... Go to Uncle Ben. And co-creator Stan Lee. Oh, this is Spider-Man. It's Spider-Man. It's not Batman. And Amazing Fantasy number 15 on August 1962, written by Stan Lee and illustrated by Steve Ditko. Just want to quickly check who Stan Lee is. Alright, don't judge me too much, but I know Stan Lee mostly from... Alright, please don't judge me. From The Big Bang Theory. I was watching this as a teenager. I feel like I'm making a confession. Like communist China style. All right, I'm gonna get water, folks. I'll be right back. Need to hydrate. All right. Notice something. Okay, so PID1 Python app. Many tiny application programs aren't designed for that role, which is why some containers use a tiny init system like tiny. What is a zombie process? Okay. Oof. When a child process finishes, so Python deploys a worker, the worker exists, but the operating system keeps a tiny record of it until the parent acknowledges its terminations and collects its exit status. Until then, it's a zombie. PID1 is responsible for ensuring orphan zombie processes are eventually cleaned up. Years ago, modern Linux would have PID1 in it, and nowadays many distributions rely on systemd. Systemd serves like services like networking, logging, SSH, cron databases. Basically, the core of what is Linux is started by this PID1. Connection to what we learned. So far, we've discussed RAM, CPUs, virtual memory. Now we've addressed processes. Each process has its own virtual memory space, its own PID, and actually parent process. Wow. Okay, so the kernel is the main thing, and then the PID comes above. All right, woof, we got in a hot sauce there. We're looking at virtual addresses and physical addresses. Cool, let's go back a little bit. Woof. PID1 is usually in ring 3. What does that mean to be in ring 3, Purpose Drifter? What does that mean to be in ring 3? Folks, for those of you that are joining now and a little intrigued by what we're doing, we're your cyber doctor, and we usually hack AI. But sometimes I feel like we're lost a little bit in how the AI works, how things are done, and so we're going back a little bit to understand the basics of AI and also computing, which is why we're learning about memory addresses and the difference between physical address and virtual address. So two different things. And yeah, just going back to the basics of computing. and we're talking about it all together so we can learn together. It says Process Drifter, who I think is a little bit more advanced than we are in terms of cybersecurity and computing in general. So it's great to have some people on board as well. On board our ship to tell us about where we're headed. So, where are we going next? Where are we going next? We are going where are we going next? All right, we've seen virtual and physical addresses. That's pretty cool. All right. Rings are security spaces. Ring 3 is user space. Ring 0 is kernel space. It's segmentation so that your ring is not supposed to be able to cross rings. So crashing ring does not crash into ring 0. Okay, interesting. Let's look more into it. Tell me more about these rings ideas. Like ring 0, ring 3, etc. It's a very cool idea that Purpose Drifter shared with us. And let's explore it a little bit. We need to just close the door a little better. So excellent, you're now getting into the operating system territory. The concept of CPU privilege rings is one of the most elegant ideas in computer architecture because it answers a fundamental question. How do we stop a random program from taking over the entire computer? Imagine if every program could directly access RAM, the hard drive, or shut down the CPU. One bug in your web browser could destroy your entire operating system. Yeah. So it's basically... Wow. Folks, I'm going to make a parallel here. It's basically the least privilege, but applied to services. Do you know the least privilege principles? It's the idea that you should have to the least privilege accessible. So if you only need to read something, you will only get to read that one thing. You get it, yeah. You will only get to read that one thing. But if you need to write it, you will only need to be able to write it. If you need to read it and write it, you only get access to that. Because if everyone had always the same permission to get everything done, our computers would be unbearably useless. Unbelievably useless. You got us right away. Thank you very much, Purpose Drifter. So this explanation of saying it's need to know before systems. Rings. Rings. Man, my freaking pen won't work. Rings is basically need to know, but for system services. Okay, that's pretty cool. So how does a random program stop from talking over the entire computer? That's really, and again, a simple way to explain it. Thank you very much, Purple. Wow, you're complimenting me. Damn. Thank you. Imagine a castle. You think of it as CPU as a castle. The closer you get to the center, the more power you have. Ring 3 is user applications. Ring 2 is device drivers. Ring 1 is device drivers. And operating ring 3, where ring 1 is operating system level. Ring 0 is the king's throne. Ring 3 is outside the castle wall. User 3 is user mode. This is where almost everything you interact with runs. Example. So, purpose drifter. Does sudo have anything to do with that, or is that another thing? I feel like sudo kind of gets close to that idea. When you use sudo, for instance, on Linux, you borrow higher privileges, but it doesn't really change your ring, does it? It's just elevating privileges within that layer, right? These programs are not trusted. Chrome, VS Code, Spotify, Discord, Python, Steam. Yes, sudo is when you're updating firewalls and you need things that are generally related services that are not in ring 3. Okay, so it is a bit related. Because they might have bugs, they might have malware, they might crash. Yeah. So the CPU says you may execute normal instructions, but you're not allowed to touch critical parts of the system. Suppose Chrome tries to do this. RAM 0 is equal to 0. The computer immediately says permissions denied. Suppose it tries shut down computer. Again, not allowed. I mean, it also limits malware, right? If you have a... This basically says I'm temporary king. Okay, let me do anything. All right. So... Which is why it is passworded and your main user should not be the admin user. Yeah. Yeah, I agree. Shut down computer not allowed. Yeah. Because it also might be easier for a malware if you have access to root components, to ring 0 components. It's also easier to have more malware that is more impactful, right? Mathieu saying, oh, look who it is, the great hacker who's going to help us become billionaires. Yes. That's us right there. The great hacker. Yay. I don't know how I'm going to make... how am I going to make you a billionaire in that tier? Because if you're all going to become billionaires, I also want to become billionaires. A billionaire. Maybe we can all become billionaires by hacking the financial system to release many dollars, and therefore inflation is so high that we all instantly become billionaires. We, that includes you, nice. We all, that includes you, nice. We're all becoming billionaires then. Exactly. Natier's got it. Ah, nice. I love that sticker. It's a really nice one. There are hacks that try to leverage flaws in services that have lower ring access. Zimbabwe dollars, here we come. Nice. There are hacks that try to leverage flaws in services that have lower ring access. Yeah. Ring access. Okay, so they have lower ring access. Okay. Ring access is the kernel mode. All right, let's write this down. Ring 0 is kernel mode. It can, I think it's interesting what it can have access to. You can have access to every byte of RAM. Access to every byte of RAM. Damn, that's pretty cool. Configure CPU. CPU. Talk to hardware. Create processes. Load device drivers. Schedule programs. Basically, Ring 0 can do anything. Damn. Ring 0 can do anything. That reminds me of the Dan jailbreak, do anything now. So like in Windows, the Sprint spooler has a major flaw through the protocol because it PRC and passes in the lowest ring of the Windows OS. RPC, remote protocol control, no. Because it remote protocol controls passes the lowest ring of the Windows OS. Have you ever written firmware for hardware? Me personally, no, not here. No, definitely not. But Purpose Drifter, apparently, yeah. Purpose Drifter says, but because you need to print the spooler, you cannot Bastille Windows. Okay. I think this went above my knowledge. Above my understanding of computing. Purpose Drifter. Kind of like how it did also when you came on Monday. I think Purpose Drifter is pretty advanced in terms of computing and everything. So it's nice to have them on chat. How does Chrome save a file? It goes like this. Basically, Ring 0 can do anything. Can do anything. Ring 1. Ring 3. Applications. Do you want to see my notes so far, folks? 7:30. Yeah. These are my notes so far. I'm just overall chill. These are my notes. This is how I write. This is Brazil. Yup. Notes are good. Nice. Notes are good. Purpose Drifter is validating us. Nice. So notes are looking good. A little bit sloppy, but still readable for me. It's like natural encryption. I can read what it means, but people really don't understand my handwriting. It's not sloppiness, it's encryption. So can Chrome write directly to the SSD? No, that would be dangerous. Yep. So Chrome speaks through kernel 0, and kernel 0 decides whether to allow it. Man, this is why we say that low-level vulnerabilities are more dangerous, because you can do more things with them. System calls. This is asking politely, called a system call. For example, open, read, write, fork, exec, socket. I'm not sure what socket means. Socket is a port, no? We're gonna go onto the website. Ground control seem. Oh, wait, what? Ground control. Okay, I was on something else. Government of Canada. Gouvernement du Canada. Alerte. Vulnérabilité non corrigée liée au spooler d'impression de Windows. Mise à jour 3. Auditoire. La présente alerte s'adresse aux professionnels et aux gestionnaires des IT œuvrant au sein des organisations avisées. An alert is used to raise awareness of a recent unidentified cyber threat that may impact cyber information assets and to provide additional detection and mitigation advice to recipients. The Canada Centre for Cybersecurity is also available to provide assistance. So we're talking about a print spooler vulnerability remains on patch update 3. Way more dangerous. A socket is a network is networking related. On June 29th, 2021, a proof of concept was released for an unpatched vulnerabilities in the Windows Print Pooler, colloquially named Print Nightmare. Oof. On June 29th, okay. Prince Pooler service. Man, not easy. Okay, so why was I reading this? Way more dangerous. Okay, so yeah, when you go lower levels, it gets pretty dangerous. Did you know late 1980s to the early to mid 1990s, bill validators used in vending machines, arcade machines, change machines would accept photocopy bills. Oh wow. Tu parles français et tu es canadien. No, I speak French, but I'm not Canadian. I had to read that with the French, the Canadian accent. It relates to issues with how attacks happen and what can be exploited to reach lower rings. Nice. To reach lower rings. So vulnerabilities, part of them will want to go to lower rings to have more control over a specific machine. Interesting. So systems calls is asking politely is called a system call. These functions aren't doing a hardware work themselves, they request the kernel to do it on the program's behalf. When you write opennodes.txt, Python eventually triggers a system call. The CPU briefly switches from ring 3 to ring 0. The kernel opens the file, then the CPU switches back to ring 3. This transition happens in microseconds or less. It's crazy. Why is it secure? Imagine malware runs. It tries erase Windows command. The CPU says, what ring are you in? Ring 3. Response, nope, game over. Can ring 3 read all RAM? All right. Oh, damn. Can ring 3 read all RAM? No. Remember virtual memory? Each process gets its own virtual address space. That's why you can't really... That's also a security thing. It's not just for functioning. It also means that there's a little bit of segmentation within the CPU, within the RAM. So is this where buffer flow attacks happen? Now you get the connection. Yeah, totally. That is correct. Belgium, France, Congo, Morocco, France. All right, can you read all RAM? So is this how buffer overflow work? Also serves for security. Can ring 3 read all RAM? No. Can ring 3 read all RAM? Okay, yeah. Different physical RAM. Same address, different physical RAM. Okay, wow. Chrome cannot simply read Steam's memory because the CMMU blocks it, the kernel blocks it. So ring 3 is applications, got it. We talked about buffer overflow. Do buffer overflow attacks mess up the CPU's the RAMs location and invade into other programs' memories? Oh yeah, no, all good. My French is from France. Because I am French. And you, Mathieu, where are you from? Mathieu Kassam. Could be from a lot of places, that name. If that's your first name and last name, you could be from a lot of places. I'm gonna say like... I want to say Middle East, but like not core Middle East. Not like Saudi Arabia. Maybe you could be from like Jordan or something. If this is your first name and last name. Okay, so Purpose Drifter is explaining us a bit. They're saying, yeah, so the file buffer, like a printf statement on C or a pointer buffer overflow, you can do bytecode injections in memory spaces that are not supposed to be accessed. This used to happen when C programmers forgot the null terminator at the end of a string. Not anymore. But I think you can still do that. Canada. Ah, you're from Canada. Nice. Canada's a big place. Canada's a big place. You're from the south, not like the north, like just the regular part of the country. Not anymore. I mean, there's still buffer overflow attacks, no? They're rarer, but they still happen, no? Purpose Drifter. Excellent connection. You're thinking like a systems programmer now. Jeez. The answer is not usually. Modern buffer overflow attacks typically do not invade others' program memory because virtual memory and process isolation prevent that. Okay. It's very rare. Most of these problems are patched, but like the print spooler in Windows, not everything is patchable. So there's just things that we have to realize just exist and there's no way around it. Most of these problems are patched, but the soul spooler in Windows, not everything's patchable. Yeah, correct. Oh, nice. Some things are just too hard to fix. Yeah, like coding vulnerabilities. We talked about, folks, if you know a bit about my past, I don't think anyone on the stream knows about this, but I used to focus on medical device cybersecurity. Maybe actually XR/Cyberpunk Reno knows. But yeah, we used to focus on, it's kind of a funny story. I used to focus on medical device cybersecurity. Really fun topic, folks. If you're ever looking for, I think it's a fun one. I left it, but I think there's some really cool things on this. It's like it's a nice field. And one of the things that the CISA, so the CISA is the Chief Cybersecurity Agency in the United States, recommended to stop using C because C and shift to other programming languages because they had inherent vulnerabilities. Not necessarily buffer overflow, but in general, C language is more hackable. And maybe you can tell me more about what you think, Purpose Drifter. Because basically the advantage of using C in your medical device, hang on folks, you're gonna get this. The advantage of using C in your medical device is that you get a lot of control over its hardware components, right? It's easier to program in C because you have a lot more flexibility in the features you can develop. It's just, and as a programmer, it's just nicer because you have more control over what happens. And as a medical device professional, control is what you enjoy. Risk is less what you enjoy, right? You want to control the medical device so it serves the purpose that it's supposed to serve and it doesn't start going bananas, right? Because your pacemaker, if it has a bug and it starts, killing patients, leading to their deaths, it's really not good for you. Like as a company, as a person, and just ethically, it's wrong, right? You shouldn't do that. But at the same time, using programs that have this much control over the hardware also makes them more vulnerable to cyber attacks. So this is why I came up with the idea, hey, it'd be nice to focus on medical devices because there's such a high need for cybersecurity on that. We need to take care of that. I thought C gives you more control. Yeah, I think that this is what I meant to say. All right, let's read a bit your comments on this. My first name can be Persian Arabic. Okay, nice. This is why I was aiming for Jordan. Mathieu. Born East Africa, Kenya, Nairobi. Till 4, lived in Canada after that. Ah, okay. That's now nice. Do you go back sometimes, Natir, to Nairobi? I would love to go there. The thing about Kenya though is that the thing about Kenya is that it's a lot about safaris, and I'm not a big fan of those. But I would love to go there. There. Right there. Your cyber doctor, live streaming. This is a place I would like to go. And look, it's pretty close, huh? What is that? 120 kilometers? 80 miles? 75 miles? Nairobi. This is Africa, folks. This, for American folks, this is the country of Africa. I'm kidding. Don't start a war on me. I'm kidding. And when I say American, I mean people from the United States. Usually other people aren't like that. It is a flaw in how Windows functions. The only way to fix the sprint pooler would be to completely redesign the entire operating system and rings and the protocols used in Windows and what domains they are crossing. And that's not going to happen. Wow, damn. When a vulnerability is this deep inside an operating system is when you know and you realize the extent of those. I thought C gives you me more control. Yeah, that's true. You cannot write hardware drivers with Python. Yeah, exactly. You need control. The reason why Purpose Drifter is saying you cannot write hardware drivers with Python is because Python is not a language that gives you access to the core functioning of a computer like something like C does. C, ASM are the two kings for hardware, firmware, low-level drivers, and cross-platform compatibility. Exactly. So you need these languages like that. And the geekos here. You can, by the way, drivers are a lot simpler than you would think, especially user mode drivers. Interesting. Not simple perhaps, but you would be amazed how simple they could be. Nope, never been back. It's been in Canada over 30 years. Wow, country of Africa. You've never been back. You have to go back, man. To Kenya. I mean, I understand you were there until 4, so like it's not a country that's like deep in your heart, right? Because you left if you were 4. When you're 4, you don't realize the environment you're in. You just know your parents and maybe your siblings. So yeah, I get you on that. But man, if I were you, and of course if I could afford it, I would definitely go to the place where I was born, especially in Nairobi. It sounds like a lot of fun. Country of Africa. What is the capital of Africa? It's what would Americans say to that? What is the capital of Africa? It's Kenya. Alex and KDev asking the tough questions. Alright, Purpose Drifter is going deep here. Most C programmers are terrible at security and resolving undefined behavior. Many things in C require doing things that many programmers deem dangerous, unsafe, and prone to errors. They are correct, but C was never meant to be a safe language. Yeah, this is exactly what we talked about in medical devices. But C was never meant to be a safe language. It was doing the things that nothing else can, where doing stretchy things might be the only way to make it work in constrained spaces. So yeah, in French we have a word called bidouiller. I'm not sure if anyone speaks French here. Bidouiller en anglais. Tinker. Fiddle around, kind of. Hack up. Is it tinker? Tinkering. Basically, C is a language that requires tinkering because it's like a it's like clay. Is it like clay? It's like clay. It's like clay. You have to make it work a bit your own way. The capital of Africa is Wakanda. Mathieu helping us out on our geography knowledge. The Geeko. It does. I'm not a fan of Python, but you can 100% with a driver in it. I'm not a fan of Python, but you can 100% drive a driver with it. Write a driver with it. Yeah, you think so? The Geeko? Looks cool. TinyGrad is a prime example of a collection of drivers written in Python. It's a driver stack from multiple GPUs, the driver stack for AMD GPU, interferes directly with a GPU firmware. You have the idea. C coders are literally low-level thinkers. I don't necessarily understand the Geeko one, but what you say sounds pretty cool. All right. Buffer overflow. Okay, RAM's location invade into other programs. Okay. So, just like we said, folks, buffer overflows are a little bit things of the past. A little bit. Because why? Because now we have safer languages. Now we have better trained people on such things. Like programmers are more trained. This is reason number 2. Programmers are more trained when it comes to knowing vulnerabilities that are associated with C. And 3, we have better tooling to prevent these silly errors. And this tooling also includes LLMs. Yeah, do you know SAST and DAST? SAST is static analysis of software. And D is dynamic. Static application security testing and dynamic application security testing. So SAST is very, LLMs are really good at SAST, no? I think they would be very good at SAST because it's about recognizing certain patterns. Oh, okay. No, LLMs are not good standalone SAST. They excel at contextual reasoning and triage, but fail at strict data flow tracking and determining rule matching required for deep analysis, static analysis. Okay, so I was wrong about that. LLMs don't have global code understanding. LLMs have limited context windows and cannot reliably trace a variable through dozens of files or complex multifunctional call graphs. Cause hallucinations and false insecurity. They frequently invent vulnerabilities that do not exist or mere real ones hidden across structural application layers. Lack of determinism. Traditional SAST use exact abstract syntax trees, AST, data flow rules, LLM guess patterns, and based on probabilities rather than computing execution paths. Where LLMs actually help in SAST: noise reduction and triage, filtering out false positives and produced by traditional rule-based SAST engines. Remediation guidance: explain why a flag line is vulnerable and writing precise patches for developers. Hybrid integration: best results come from combining deterministic SAST tools for deep code scanning with LLMs, with acting as intelligent triage and explanation layers. Nice. That's really cool. All right, folks, you good, and folks in the chat are having really cool conversations. I like that. It does. I'm not a fan of Python, but you can 100%. Okay. I would not use any OS that uses Python in Ring 1 or 2 because it requires the runtime. We do everything with AI now, except a great comeback of buffer overflows. Why do you think that Alex NKDev, why do you think that having more AI will lead to an increase of buffer overflows? What I'm saying, with almost any programming language, you can do whatever, since at the end of the day, it just boils down to instructions, same way or another. Yeah. I mean, depends how you give instructions, right? And who you give how you give instructions. You can ask, like, for instance, if you ask an LLM how to do it, it's not going to be the same thing as if you wrote that in hard code. LLMs might hallucinate and do different weird things, and code will usually be more straightforward and have deterministic outputs. So yeah, you can do things different ways, but it's better when you do it in a way that leaves the less room for interpretation. And I think this is what C is for. I don't actually know. This is what I think I know, if that makes sense. But do people ever really know things? I'm getting way too deep here, but I believe this is my idea here, my 2 cents on this. The Geeko one says, what I'm saying with almost any programming language, you can do whatever, since at the end of the day, it just boils down to instruction some way or another. Okay, this is just what we read. Purpose Drifter, you can install MicroPython to act as a bootload runtime. The Lego Midstorm uses MicroPython in this way because it constrains, but no sane system engineer would use Python for anything critical. True. Okay. IUEM tried for more than a decade and they gave up. They come up with the same conclusion. AI sucks at doing anything that requires reasoning because they are statistical compilers at best. They're not reasoning engines. But why do they give the illusion of being so good at reasoning? I write mostly in C, but it's always interesting to have an interpreter as the core bone of a system. It makes everything dynamic. Something like Emacs. You could change the behavior of anything without rebooting or add things with ease while running. Our Purpose Drifter is challenging the above idea. Alex NKDev, because at Big Tech they expect us to produce 10 times more work with AI, it is inevitably leads to lower quality. Yeah, okay. Yeah, I agree. I don't think AI is necessarily worst at coding, but I think the rush that we're put into because of AI is the efficiency gain will lead to lower quality. That I agree with. Alex NKDev. Mathieu says, when I was looking into languages to learn, we came across this hypothesis that there will be less and less C programmers, and this is going to be an issue. Just like COBOL programmers are going to be needed soon. Maybe, yeah. I agree. I mean, there already are Cobalt. Folks, if you don't know Cobalt, Cobalt is one of the first, I mean, I don't know if it's one of the first codes, but it's one of the first codes that exists on computers that actually go through punch cards, I believe. Cobalt is a language that is going through punch cards, and so many applications that are still critical today are written in Cobalt. We still rely on very, very old infrastructure. And the guys and the ladies that were programming this for over 40 years ago are retired or dead, and so there's fewer and fewer Cobalt people. So it's a great time to get into Cobalt if you have the time. If you have a decade or two to spend on it to learn Cobalt, and you can charge a lot once you understand the service, because companies are going to be desperate for your input. When I was looking into programming to learn, we came across the hypothesis that we less and less. Okay, banking, financial systems runs on Cobalt. Nah, C ain't going away. Unlike Cobalt and other dead languages, still the vast majority of our software is written in C. Anything you can do in system, like 70% or so, is written in C, from the driver to the firmware. What do you think about things like Cobalt? I'm not saying like Cobalt, but things like Rust. Aren't they better than C? Isn't Rust better than C because it fixes a lot of these issues that C has? Isn't it more secure by default? AI is entirely statistical. It is closer to a more complex Markov chain in matrix form. They are they fire the matrix to create a single token that may not even a full word. Isn't it cobalt? Yes, sorry. Okay, you are correct. I want to check one thing. I want to check here. Why are LLMs not deterministic? Like, why do they have like some kind of variance? Why, when I run this twice, will it not be the same? If the weights of the different nodes are the same, then why are we struggling with that? This is one of the best questions you can ask about LLMs because it reveals important distinction. LLMs themselves are deterministic. Aha. The text generation algorithm often is not. Dun dun dun. Let's define deterministic. A deterministic machine will always produce the same output given the same input, given the same model, given the same settings, given the same hardware, or mathematically equivalent computations. Makes sense. For example, 2 plus 2 will always be equal to 4. Yep. As an LLM is just a giant mathematical function, matrix multiplication, ReLU, matrix multiplication, output, we don't understand, but we kind of understand. There are no random decisions inside these computations. If the weights are identical and then the input is identical, hello will always be equal to the same vectors. So far, so good. Hey, thank you very much. OTWLV, thank you very much for joining the squad. Appreciate it. Welcome, welcome. Where does randomness enter when the model computes probabilities? Suppose the model predicts cat, dog, mouse. Now the system has a choice. Option 1, greedy decoding. Always pick the highest probability every time. Completely deterministic. Option 2, sampling. Treat the probabilities like weighted lottery. Imagining a bag containing 100 balls. Shake the bag, drum one, maybe you get dog. Next time you get cat. Next time you get mouse. Same probabilities, different outcome. But doesn't this increase the computing amount by a lot? If you get it random every time? Why sample at all? Imagine asking, write me a fantasy story without sampling once upon a time. Every single user would almost get exactly the same story. Sampling allows creativity. Ooh. Temperature changes how random the sampling is. Suppose the probabilities are token, cat, dog, mouse, temperature 0, cat, 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 cat. Okay, always. Temperature is equal to 1, mostly cat. Sometimes not. This is what temperature is about. Okay, so this is really good. This is really good information. LLMs are deterministic. What isn't is the text generation. You can set the model's level of deterministicness. Does that make sense? Level of deterministicness by changing the temperature. Temperature is equal to 0 means no variation. All right, let's try it. Can we try this on ChatGPT? But we'll try 2 different chats. New chat. Duplicate tab. And I'll get to the chat because I'm a little late on things. On your chat here. We're gonna say, what is love? Temperature is equal to 0. Can I do that? What is love? Control C, enter, and now we type exactly the same thing here. Will the 2 outputs be the same? Ah, it's not the same thing. It's not the same thing. Love is a deep, enduring... Nope, it's not the same thing. We don't get the same thing. Biology, philosophy, every day. You see, but the bullet points are very similar. It's interesting. Did we set it to 0? Yeah, we did set it to 0. Okay, so still, I think ChatGPT just didn't apply this directly. It just understood it. All right, cool. Let's get back to the chat. AI is entirely statistical. It is closer to a more complex Markov chain in matrix form. They fire... I don't know what a Markov chain is. I'm going to write it down for a future question. They fire a matrix to create single tokens that may not even a full word. Isn't it cobalt? Yeah, sorry. Yes, you're correct. It depends. Rust is good to use and safer with saner defaults, but the amount that is written in C is huge. It's not overestimating it. There's no overestimating it. Hey, we got a raid. The Shy Hat. Thank you very much. 14 viewers. Hello, everyone. Welcome. We're just about finishing our stream to the Shy Hat, but pleased to have everyone on board. I'm going to get to the chats and welcome you folks in a second. Let me just catch up because I have 8 minutes of delay in my chats currently. I agree, C is extremely important, but there are very important critical systems that run on Cobalt. They can be replaced by other languages. Folks, if you don't know the Shy Hat streams several times a week, usually longer streams than we do. And they're focused on cyber stuff just like us. And with a little bit more, I want to say a little bit more gaming aspect to it. There's a few more games that involve cyber concepts as well. So very fun stuff. I suggest that you follow him if you haven't yet. And check him out. He starts streaming a little bit earlier than we do and ends about the same time because we're about to end. But I think we can stay a little bit longer. It's set to 0. When you use APIs, you can change the temperature to set to 0, the same output. But most AI sit around 0.8, adding 20% randomness to the reply. So folks, we're talking about why LLMs are not deterministic. And deterministic, all right, let's get back to the chat. Hip Hop Hack, nice. Hello everyone, Purpose Drifter. SysO Master is here. Ooh, SysOS Master, the Shy Hat. I gotta get going, but hope you're right. Someone cool later. Of course, the Shy Hat. Purpose Drifter. I was wrong. The geek is correct. The temperature is introverted. Today was a co-learning stream for C. No way. It was a co-learning stream. We're a little bit on a similar vibe here. Nullsec is here. Deterministics means the same input will always output the same output. Love it. It's the most simple way to explain it. My LLM is messing up. LLM is not deterministic because it's made it to be non-deterministic by design. So, yeah, it's made to be LLMs are actually deterministic. This is what we learned today, SysOS Master, is that LLMs are deterministic. It's just that the text generation that goes beyond them, is not necessarily deterministic. So, if your output, if you say, the LLM will always calculate the probabilities of each word being next. And what you can say to the text generator, you can say, dude, just take whatever is the highest probability. Just takes always that. And I assumed that's what it was. But apparently that's not what you do. You want to have some kind of randomness so that, you know, it doesn't sound too generic. Temperature, fair enough. So you want to have some kind of randomness. And so this is what the temperature is all about. It's about regulating how creative you want the LLM to be. How wild do you want the LLM to be? And the more wild you let it become, the more inconsistent it will be, but the more creative it will be as well. Just that. Only if it's extremely strict, it will be deterministic. But also the input can affect the weights, making it non-deterministic. Yeah. Yeah, so the input can't. I mean, the input is also the first word. So it all depends on the first word that you choose. If you start with the sentence, if you start your reply with the word the, that already sets up your whole response, because you cannot start with I afterwards. You cannot say the I. Right? So if there's one component that's not deterministic, then the rest of the output will not be deterministic either. The one following that. So that's kind of cool. Hope that makes sense to you folks. Hope that makes sense for you folks. Randomness is not calculated. The GPU, the LM gives it out a list of words, and then one is selected from them. Exactly, the Geeko. That's also how I understood it. And not always as random as you think. Entropy is deeply troubling. Man, you love that conversation, huh? So Purpose Drifter was on the chat as well on Monday when we streamed, and we talked about the principle entropy, which is the idea of which is a contributor to randomness. And randomness is difficult to achieve in computing, simply because computers always rely on a preset of variables to find this random variable, to find this randomness. So there's no going around it. Randomness is hard to find. From what I understand, in any kind of programming applications, you cannot have true randomness. So at the end of the day, it has to be deterministic. That's true. All right, you folks are being in the details here. But I love it, huh? We need to be in the details and challenge each other's ideas. Also, floating point arithmetics, computational mode inconsistencies make them non-deterministic in a way. Huh, interesting. I didn't think about it that way. That's true. Yeah, I know that's the recursive part. Okay. Epistemic arcanesis here as well. Cool. You can, but not through an algorithm. You need something non-deterministic as a source, like a floating input. Tell me about it. I worked as a graphic dev, mostly writing lightning shaders and compute kernels. Floating point errors are pain. Oh, I need to learn what floating point is, huh? Point. So, folks, I think we're going to talk about it tomorrow. Markov chain, floating point, and we're going to pursue this this whole topic. We're going to end it for today. But hold on, we have a few more things to do. Pendants, you can rank him in the tier, I see. Well, there's a lot of people. The Geeko decided to follow. Thank you very much for following. Appreciate that. Welcome. Nice to have you as part of the club. Folks, if you're feeling like you want to be part of a wider community of people who hack AI, I suggest you follow our Discord. Because it's really fun. We talk about AI things. We had Purpose Drifter there on Monday detailing a bit more about it, about their perspectives on certain topics going on in computing, like entropy and stuff. So yeah, some good stuff there. You're Cyber Doctor. Do you program in C? What's your tech background? Ooh, good question. Natir, I don't really have a tech background. The only tech background I have is I have a master's in business analytics. So I know some things about, I know how to code a little bit in Python. I know I know how to make the what's it called, the PowerShell work. Not PowerShell, but the Linux kernel. I know a little bit about it, but other than that, I don't really have a programming background. I'm more of a business person. I right now work in cyber insurance. So my job consists of understanding companies are like, hey, can you insure us? And I go like, yeah, give me a little bit of information about yourself, how you protect your company, and also what do you want covered? Do you want this or that covered? And then afterwards I give them a price and then we negotiate. This is basically what I do. And so it's not as much in going computers. We won't actually check their computers and be like, all right, you have this vulnerability patch X3349 CVSS 3.4, and it's still not patched in 2022. We're more relying on macro information, like how do they make decisions, what are their priorities, how do they handle AI risk, how do they handle different kind of risk around their organization. This is what I do, and I make decisions on that. And this is why I want to become a little bit more technical to understand how things work. And look what we learned here. All right, we're talking about entropy again. Ay, ay, ay. So that's my background. Nice, I see. Yep, that's what I do. All right, folks, we're going to do a quick GeoGrid game. No, not GeoGrid game. We're going to do a map tap. .gg. It's a quick, because we talked about the geography of... oh, there's the moon. I never noticed. There's the moon and yeah, this game, because we talked about the geography of Africa earlier. And so we're going to talk about, we're going to do a little game of geography. Oh, you don't see it. Ha ha ha. There it is. So folks, this is planet Earth for people that have ever been there. This is the country of Africa, country of Europe. This is, all of this is the country of the Middle East. And all of this is China. Yeah, over here is China. All right, so we're gonna do a quick geography game. The country of Europe. Yep, all of this is new. All right, I gotta figure out where Maryland is. We're just gonna do this, and then we're gonna find a nice place to send you folks over to. So Annapolis, Maryland. This is New York. I have no idea where Maryland is. Kind of forgot. Annapolis, Maryland. Where could this be? Where's Maryland? Is it? This is Connecticut, I think. Is this Boston? I think this might be Boston. This is Boston? I think this might be Boston. Boston's in Massachusetts. Maryland. Is it higher? Close to DC. Close to DC. All right, we're taking the hint. This is Washington, DC, I believe. All right, I'm just going to click here. See what happens. All right, nice. We're 36 kilometers away. Nice. Oh, it was right there. Close to DC. All right, nice. We get a little help. Close to Brisbane, Queensland. I think Brisbane is like over here. Is this Brisbane? I think it might be Brisbane. I think this is Brisbane. Pretty damn sure. Mao seeing China this big. I agree. Even Shia. I think this is Brisbane, I'm pretty sure. Could it be this? No, it's too small. This is like Darwin or something. Nice, we got it. Score 100. Cool. Alright, Helena, Montana, USA. Alright, this is gonna be a tough one. Montana's like over here, no? Helena. Is there a city around here? This looks like a city. Does this look good to you folks? Montana. Maybe it's more on the left, no? Because here you have Oregon. Right? And here's maybe here. High left. And today we cheated a bit. All right, let's go with this one. Or is it too high? Not on the coast. Yeah, I agree. It's like here, no? Null sec. Helping us out. All right. Helena, Montana. Where's the city here? There's a city like here. Okay, we're not far. That's pretty good. Did it look like a city? Okay, it did look like a city a little bit. A tiny city. Chopiaco, Chile. All right, there's 2 more cities, folks. Atacama is a desert in the north of Chile. This is... Oh, thank you very much. Slumdog Arch is here joining us. Thank you very much for the follow. Appreciate it. We're not a geography stream, huh? We're just doing cyber and sometimes enjoying a little fun. So I believe this is the salt lake that's in Bolivia, and right here starts being Chile and Atacama. But it's a little hard to see where towns are. Is that a town? That's not a town. This looks like a town, no? Right there. This is a town right there. Let's click and see what happens. Ay, ay, ay. Alright, so Atacama is a little bit larger than I thought. I thought it was just the north, but it's goes a little bit longer than that. Alright. Petropavlovsk. Kamchatsky. Alright. This is a challenging one. Chamkatka. Alright. I believe this is a Kamchatka Peninsula. So we have to find a city there. Probably it's the largest city in the island. Current AI is dead. Yeah, I don't fully understand, but I think I agree. All right, you're all having the conversation about AI. All right, I'm here trying to find the place in Kamchatka. All right, this is the last guess, folks. I see kind of a city here. Man, it's pretty dead. Kamchatka. Petropavlovsk. Petropavlovsk. Where could this be? I think this is the most city thing I've seen. Ay, ay, ay. 700 kilometers away. Did it look like a city at all? Yay. People are cheering. I want to go back to Petropavlovsk on the Kamchatka Peninsula. Oh. Wait, what? What is this? Alright, so Petropavlovsk looks like... Okay, kind of looks like a city. Could have guessed it, but our guess wasn't too bad. Cool. That was a geography minute, folks. We got 900 points. There's no way to chain, grow, or scale AI for some reason until a different type of formula matrix training process that creates different domains than what we have. You're just going to make more of the same entropy, not better entropy by scaling. So you cannot reach AGI by scaling current systems because they are constrained in the same way. Sorry, my LM is glitching, but hopefully the core ideas are understandable. What do you mean my LM is glitching? Maybe Purpose Drifter has been an LLM all this time. Being a long crunch of data to understand why this happens, only to be finding entropy is bigger mess than most people understand, and why some people should be researching it. Because if we don't solve the entropy problem, we're not going to solve the path to AGI. Maybe AGI is not that required, huh? Just as a side note, maybe we don't need AGI. I kind of want my job still. Kind of want to exist as a human being. I'm not sure if AGI is a great thing for us. Alright folks, this has been it for us today. Where are we sending you folks to? one of the hardest questions I asked my life. It's a niche application that will remain. Unleashing 3 AI in Minecraft. Oh, that sounds pretty fun. Hold on a second. There's someone that's creating AIs in Minecraft. That sounds pretty fun.
And so I've got a way of like running these scenarios.
All right, little Dorito ad, of course. Come on, I shouldn't have an ad when I join a stream, no? Do you folks ever get ads when you join my stream? I don't think you should.
The idea is that we choose something. Let's choose something.
I put the ads to the minimum.
Like vertical switchback, and we're going to set the repetitions to 1, and we're going to start.
Okay, this looks really fun. What this bro is doing. Let's go rate him. AI Bengineering. Oh man, love that name too. Bro, I'm jealous of him. He just started. That looks really fun. Oh my god, let's go. Is that slop in Europe? They sell that in slop in Europe? What are we talking about? Doritos. Ah, right. I guess so. Yeah, we took that from you. I think there's even Cheetos. There's even Cheetos. So there's plenty of things. Folks, it's been an absolute pleasure to have you today. We will be streaming tomorrow in 21 hours and 34 minutes. 21 hours, 34 minutes. Set your timers. And we are about to go. We are about to raid a viewer. No, not a viewer, but a channel. So what are we going to say when we go there? What are we going to say? We're going to say... What are we going to say, folks? We have to figure it out. We have to say, thank you for the stream, Doc. You're learning a lot. Thank you very much. And you're bringing a lot of cool ideas. Purpose Drifter. I very much like that. So we have to raid and say something. What he's doing looks really cool. I'm not always happy with the people I raid, I gotta say. Sometimes I feel like, oh, I gotta raid, but I don't find someone cool. But this guy seems to be doing something really fun. So let's go check it out. Time for a checkup. Love it. Vamos. Let's go and say time for a checkup. See you, folks.